If you're watching this video, you'd like some help making your model to describe what happens to molecules when thermal energy or heat is added or removed. The first thing that you're going to need to do is to set up your paper. You're going to need to draw 3 bottles. One that represents the air in a closed system in just room temperature. The second is representing air in a bottle that's placed in cold water. And then the third bottle represents air that's placed in a bottle that's then put into a warm or hot water bath. So the first thing that you're going to need to do is set that up. I've drawn mine here. I'll wait for you for just a moment, or you can pause the video for you to create your model. Okay, so now that you've made your model, the first thing that you should have on your model is the first bottle of air in room temperature. The molecules have already been drawn in. The arrows showing their molecular motion. It's of a average little length. It's not too long and it's not too short. And we also see that there is energy that is being transferred in from the outside of the bottle, but there's equal energy transferred out here, since the temperatures inside and outside the bottles are the same. For our second bottle, we're going to be making a model of the air in the bottle placed in the cold water. So we are going to have to think about the number of molecules in our bottle. Because this is a closed system, in other words, no material can get in or out, we need to have the same number of molecules. But we have to think, are they going to be placed the same way as these molecules? Are they going to be closer, or are they going to be farther apart? Well, this water is cold, so we need to place our molecules the same number of molecules as in the first model in our second model. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm going to need to draw 15 molecules that are closer together, but the same size as my original molecules. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, we also need to think about how these molecules are moving. In a cold situation, we need shorter arrows because the molecules are moving slower. So, and because the molecules are moving in random motion, I just kind of need to put these arrows going all sorts of different directions. The molecules do not control the direction that they move in. But our arrows need to be shorter. All right. So the next thing that we need to add to our model is the energy that's transferring. So we need to think about the temperature of the air inside the bottle and the temperature of the air outside the bottle. So I know that the cold water is on the outside of the bottle. So we've got colder air on the outside. So we've got colder outside and warmer inside. So, energy transfers from an area of warm to an area of cold. So, since our inside is warmer, we're going to have more energy going out. So I'm drawing a bigger arrow for energy out, then I'm drawing for an arrow for energy in. So, because I know that the air is warmer on the inside initially and colder on the outside, I need to make that energy transfer. So, when we make our last model, air in the bottle placed in warmer water, we need the same number of molecules again, so we need those 15 molecules. We're going to need to show how those molecules are moving. Remember, we used a shorter arrow to represent that the molecules are going to be moving slower. So we're going to need to have a longer arrow, and we need to talk about how the energy is moving. Remember, once again, the energy is going to move from the outside, going to move from the higher energy to the lower energy. Make sure you finish up your model and take a picture of it and post it in your document.